Hello everyone, this is Ajay and you are welcome on my YouTube channel, which is Math Cafe. So this one is the part 7 of our topic, which is matrix, and this video is all about transpose of matrix. So first of all, we will see definition of transpose of matrix. So transpose of a matrix is represented by A transpose, A power T, A transpose or A dash, alright, and is obtained by interchanging all the rows and all the columns to each other. Alright, so if a matrix is of order m cross n and I am going to obtain A transpose, then order of A transpose will be n cross m. Alright, because I am going to interchange all the rows and columns, so there are m rows and n columns, so in the A transpose there will be n rows and m columns. So let's take an example here. If I take first example, if A is represented by A11, A12, A21 and A22, and we need to obtain A transpose. Alright, so how will we obtain A transpose? So A transpose we will obtain by interchanging all the rows and columns. So this is row number 1 and this is row number 2. So we will put row number 1 in column number 1. So row number 1 will become column number 1. So A11, A12, and row number 2 will become column number 2. So A21 and A22. Alright, this is simple. So let's take another example. Example number 2 is here. If A matrix is written in the form A, B, C, D, E, F, G, H and I, and we need to obtain A transpose or A dash. Alright, so let's proceed with the solution. So A transpose will be obtained by interchanging all the rows and columns. So row number 1 will become column number 1. So A, B, C, and row number 2 will become column number 2. So D, E and F, and row number 3 will become column number 3. So G, H and I. Alright, this is simple. Let's take another example, example number 3. If any matrix B is written in the form 1, 2, 3, 4, 5, 6, alright, and we need to obtain B transpose. Alright, so simply we can obtain B transpose. Let's proceed with the solution. So B transpose will be obtained by interchanging all the rows and columns. So row number 1 will become column number 1, 1, 2, 3, and row number 2 will become column number 2. So 4, 5 and 6. Alright, order of this matrix is 2 cross 3 and order of its transpose is 3 cross 2. And if you notice that B is not a square matrix, and still we can obtain B transpose. So it is not necessary that given matrix is a square matrix. So let's take a note here. It is not necessary that A is a square matrix. Alright, that A is a square matrix. It is not necessary. For non-square matrix we can obtain transpose. Alright, see here some properties based on transpose of matrix. Alright, so first property is here. If I take A transpose of transpose, then this will become A. A transpose of transpose, that means I am interchanging row and column 2 times, so we will get the same matrix. In property number 2, we will see that if I need to find determinant value of A transpose, that will become determinant value of A. Alright, in this case A should be square matrix. In this case A should be square matrix, as we already know that we obtain determinant value for only square matrices. Alright, let's see here third point, that if it is written Ka and we need to take transpose of this value, then we can write it as K times of A transpose. Alright, so in the fourth property we will see that transpose trace of A transpose will be equal to trace of A. Alright, and we can understand property number 4 in any square matrix of 3 cross 3. So if I obtain trace of A, so trace of A will be A plus E plus I, sum of all the diagonal elements, A plus E plus I. Alright, if I obtain trace of A transpose, that will be A plus E plus I, A plus E plus I. So what we observe here, that trace of A will be equal to trace of A transpose. Alright, so let's see here property number 5, that if a matrix is written in the form of A plus B plus C minus D. Alright, if we need to take transpose of this matrix, then I can write it as A transpose plus B transpose plus C transpose minus D transpose. So I will just put transpose on each matrices. So A transpose plus B transpose plus C transpose minus D transpose. Alright, let's see here property number 6. If it is written that A, B, C transpose, so I will write it as C transpose multiplied by B transpose multiplied by A transpose. Alright, so I will put transpose from back side, so C transpose multiplied by B transpose multiplied by A transpose. Alright, property number 7, that is last property. If it is written A raised to n and we need to take transpose of this value, alright, so this will be equal to A transpose of A transpose raised to n. Alright, and we can see proof of this property number 7, A power n transpose. So A power n can be expressed as A multiplied by A multiplied by A n times. Alright, and we are taking transpose of this value, so I will just put transpose from back side, so that will be A transpose multiplied by A transpose multiplied by A transpose multiplied by A transpose n times. So I can write it as A transpose power n. Alright, that is simple. Hope you understand this lecture. In the next lecture we will be seeing about symmetric and skew-symmetric matrices. So if you have any doubt, you may ask in the comment section. So see you soon in the next video. Till then, bye, take care and keep learning.